In this video, I'll be reviewing the Unit 11 study guide for exponents. So as always, the first page of the study guide is just a review from your notes. So go ahead and look over that section if you need help or some review for order of operations or exponents. Our first problem that we're going to go over, it says, what is 10 to the 5th power? So we're going to write this out in expanded form. And when we write 10 to the 5th power in expanded form, remember that we're doing that repeated multiplication. So we're writing 10 times itself 5 times. So the answer for this one should be C. 10 times 10 times 10 times 10 times 10. It is not 10 times 5. Remember, Taylor Swift says that we are not allowed to multiply the base and the exponent together. Looking at number 2, it says compare using less than, greater than, or equal to. So you need to solve both of these exponents. 2 to the 1st power would be 2. And 5 to the 2nd power, that'd be written out as like 5 times 5. And 5 times 5 is 25. So 25 is greater than 2. Now, for number 3 and number 4, they're asking for what is the perfect square that falls between 81 and 121. And remember, to find the perfect squares, you're trying to figure out, okay, what number times itself will give me that perfect square? And you can use a multiplication chart. You can look on the diagonal of the multiplication chart. So I'm going to think to myself, okay, is there a number that I multiply times itself to give me 81? Well, that would be 9 times 9. So I get a perfect square of 81. And then for 121, that would be 11 times 11 would be 121. So I'm looking for the perfect squares that fall in this blank here. So the perfect square that would fall in that blank would be 10 times 10, which gives you the perfect square of 100. So 100 is the perfect square that falls in there. I'm not looking for the factors. I'm not looking for the exponent. I'm looking for the actual square and how many pieces is it made out of. Same thing for number 4. What is the perfect square that falls between 25 and 64? So the numbers times itself would be 5 times 5 gives me 25. And then to get to 64, that would be 8 times 8 gives me 64. So there's actually multiple answers for this one. I want something that falls in the middle here. So I could do 6 times 6, which gives you the perfect square of 36. Or you could have done 7 times 7, which gives you the perfect square of 49. So you could have had 36 or 49 for an answer for this problem. You don't have to have both. You just have to have one. And remember, the square is actually the product. What does it get when you multiply them? Continuing to scroll down, which expression does not equal 16? So if I look at this, 4 to the 2nd power is written out as 4 times 4, which gives me 16. So A works. 4 to the 4th power, I write that out as 4 times 4 times 4 times 4. Well, automatically, I already know that these first two 4s multiplied together give me 16. And then if I continue multiplying by 4, I'm going to get something rather large. And it's going to be greater than 16. So B is probably not equal to 16. But let's double check the other ones. C is going to be 2 times 2 times 2 times 2, which by chance also matches D. So if we solve D, we can figure out if C works. 2 times 2 is 4, 2 times 2 is 4, multiply them together, I get 16. So both C and D equal 16. So my only answer that doesn't equal it is B. Now for number 6, it says, which of the following is equivalent to 6 times 6 times 6 times 6 times 6? So I'm multiplying 6 together, so 6 is going to be the base, and I have it multiplied 1, 2, 3, 4, 5 times, so it is 6 to the 5th power, so it should be D. All right, looking down, looking at number 7, it says solve the following order of operations problems, identify the expressions that have equivalent values. So I'm looking for the ones that are equal to each other. So that means I have to solve all 3 of these order of operations problems following GEMDAS and figure out which ones go together. So I'm going to write GEMDAS for each of these problems so I can follow it and cross it out as I go. And if I look at the first one, I don't have any groupings, but I do have an exponent. So I'm going to need to solve this 2 to the 2nd power, which is really 2 times 2. So that would be 4. Bring everything else down that I haven't used yet. I'm no longer have any exponents, so I'm going to look for any multiplication division. Remember, multiplication division, you have to read it like a sentence. I have multiplication right here in front, so 3 times 7 gives me 21. Bring everything else down. Now I have to do no more multiplication division. I'm left with addition and subtraction. So if I add here, I'm going to start from the front and work my way backwards. 21 plus 4 gives me 25. And then I still have the minus 1, so I'm going to finish that last step. 25 minus 1 gives me 24. So there's the solution for the first one. The second one, I don't have any groupings, but I do have exponents. I can solve both of them. 3 to the second power is really 3 times 3, which is 9. 2 to the second power is 2 times 2, which is really 4. Then I have the plus 3 plus 4 times 3. No more exponents. I have multiplication right here, doing it in sentence order. So 4 times 3 is 12. I still have the plus 3 and the plus 9. No more multiplication division, so I'm left with addition subtraction. Start from the front. 9 plus 3 is 12, and 12 plus 12 for my last part of the problem is 24. Now, these two are equal, so these could be my answers, but I'm going to double check this last one just to make sure I didn't make a mistake, because it says identify the expressions, so there could be all of them equal to 24. Let's check. So I do not have any groupings. I do have an exponent right here, which would be 2 times 2, which is 4. Bring everything else down. I don't have any more exponents, but I do have multiplication. I have that 1 times 3 is 3. Bring everything else down. Now I have addition subtraction because I'm done with multiplication division. Work from the front. 4 plus 3 is 7. Bring the 3 down. And 7 plus 3 is 10. So our final answers are the ones that should be our official answer would be the middle one and the first one. So those ones are the two that are equivalent to each other. All right, moving on to the last 4 problems. So again, these are order of operations. I'm going to start by writing my GEM-DOS down the side so I can follow it. I have a grouping. Now, it's not a traditional grouping because it's this absolute value here. I have to solve the stuff inside and then do the absolute value. So I'm going to do 3 times 3 first, which is 9. I still have absolute value divided by negative 81. Then I need to finish that grouping absolute value of 9. Remember, that's the distance from 0. How far away is 9 from 0? It's 9 spaces. And then I have to finish that division. Negative 81 divided by 9. Now, there's an integer here, so I'm going to have to use the triangle for that multiply divide. 81 divided by 9 is 9, and then I have to look. A negative divided by a positive gives me a negative solution. So this is a negative 9 for your solution for number 8. Number 9, this is one of those fraction ones. You need to solve all the stuff on the top before you can deal with the bottom. So I'm just going to follow order of operations for the top. I'm going to do the multiplication first. And remember, if you need to, write down that GEM-DOS down the side. So I don't have any groupings up top. That single number in a grouping is a fake out. I don't have any exponents. I do have that multiplication division. So I'm going to do 4 times 5, which gives me 20. And then you can see I have the 2 plus 20. Up top, 2 plus 20 would give me 22. So now my problem that I'm looking at is 22, and then I have the bottom over negative 2. So 22 divided by negative 2. Remember, a fraction bar means division. This is an integer problem, so I'm going to need the triangle. 22 divided by 2 would be 11, and then a positive divided by a negative gives me a negative 11 for my solution for number 9. Looking at number 10, again, writing my GEM-DOS down the side. I have a grouping of a fraction that's right here. And I have to ask myself, can I solve that fraction? And in this case, I can because it's division. So I can do 16 divided by 3, and I can get 4. And then you can look at this and say, okay, I'm done with my groupings. I need to solve my exponent. Now, if you did your exponent first in this problem, you wouldn't be wrong because the exponent's not going to interfere with anything. You could either think of this 12 over 3 as division, or you could think of it as a grouping. Either way, if you do it with this problem, exponent first or the division first and you think of the fraction bar, it doesn't matter. So 5 to the second power, I'd write it out as 5 times 5, which is 25, and then I have that 4 left. So 4 plus 25 gives me 29 for a solution for number 10. And then my last problem that I have here, so again, I'm going to write my GEMDAS down the side. And I have a grouping, so I need to do that grouping in there. So it says 3 minus 4. So if I have 3 and I take 4 away, I'm left with -1. Copy down everything else that I haven't used yet. Now, I do not have any more groupings. I do not have any exponents, but I do have multiplication division. I'm going to multiply here. So I'm going to do 2 times 1, or 1 times 2, I'm sorry. 1 times 2 is 2. Don't forget all the signs. And then the last part is I have this opposite of -2, 60 minus -2. Remember, that turns into a plus right there, because opposite of -2 is a +2. So 60 plus 2 gives you 62 as your solution for that problem. So if you do have any questions on your study guide, make sure that you reach out to your teacher. And thank you so much for your hard work.